Hi everybody, my name is Restrepo and I'm part of a very cool group of software engineers at Major League Soccer. I am also a computer science student and an occasional open source contributor for a Great Helper, a React Native community project. Most of our products at MLS are built or being built using React Native or React.js, among of course other technologies. Today I will cover a topic that has been really major for our mobile app at MLS. It is bridging native modules with our React Native application. And here is the agenda for this talk. I would like to first briefly go over that thing called the bridge. Then go over the state of it, a close-up to React Native's new re-architecture, and also talk a little bit about the bridge under the hood. How is this piece of React Native's architecture set up, and how does it really look like inside React Native's core? Lastly, I would like to cover a bit of how to bridge native modules with React applications for those who are just getting familiar with the platform or need a refresher of how to actually connect the bridge to React Native applications. Okay, so what is that thing called the bridge? Let's quickly revisit the concept in the React Native context. The bridge is that part of React Native's core that allows us to send and receive messages to and from JavaScript land. Let's say you have a native module that most likely belongs to a third-party provider, like in our case, or you definitely need it to develop in native language for performance or capability reasons. Or let's just say that you need to use an API that has been written in native code. This platform module or API, however you want to call it, needs to communicate with the rest of your app that you have been arduously developed in JavaScript, and also manages the rest of the functionality, of course. This is where the bridge becomes necessary. It allows this communication between those two pieces of your app through asynchronous JSON messages that get batched and sent from one side to the other. It saves us from having to re-implement things in JavaScript. So, what is the state of the bridge as per today? Emily Jensen from the React Native core team at Facebook talked on this conference last year about the direction of React Native for 2020 and React Native's re-architecture. Among the changes she talked about, turbo modules, initializing React applications without the bridge, and the introduction of JSI were the most important in what relates to this presentation. So let's have a refresher on what these topics entitle. The 2020 version of React Native will include what is known as turbo modules, which is what is considered the new generation of implementing the interaction with the native side. Turbo modules, in conjunction with Fabric, allow for the UI manager to create something called the shadow tree directly in C++, which reduces the overhead of calling JavaScript methods from the native side and significantly improves the responsiveness of the user interface. Turbo modules will include improved type safety between native code and JavaScript and allow for less overhead calling methods from JavaScript, and also are faster to start up. Let's move to what the new initialization process for a React app will be. Initializing without the bridge is also one of the major changes in React Native's re-architecture. During the initialization process, React Native loads classes, initializes native modules, initializes view managers, and sets up the bridge. The new architecture aims for no longer eagerly initializing native modules and view managers, and instead, those two processes will be initialized lazily, which again is a significant improvement in performance for our apps. This new way of initializing our apps is directly related to the introduction of JSI. JSI stands for JavaScript Interface, and it's an API that allows us to interact with the JavaScript engine from C++. It allows us to create JavaScript runtime, load the JavaScript bundle, and call functions between C++ and JavaScript. It also allows us to create and access JavaScript objects from native code, which is actually pretty cool. GSI is the promise to solve the main issues that having a bridge in between native modules and JavaScript content implies, such as bottlenecks and the lack of awareness from one side or the other with asynchronous batch messages. And okay, I am going to stop here for the recap of what the new architecture of React Native is. But if you want to get a deep idea of the evolution of React Native and the process of coming all the way to what it is today, I recommend to watch Lorenzo's Chandras. Pardon if that's not the way you pronounce your last name, Lorenzo. His talk during React Advanced 2019 conference in London, where he takes a deep dive into React Native's evolution. Also, there is this article by Remy Gallego that summarizes React Native's re-architecture in 2020. They both serve me as the references to prepare this part of my talk, and I consider them really useful. So it is worth you go and check it out. Okay, let's continue with the bridge. Even though Facebook's plan to eventually get rid of the bridge is coming a long way, many applications and modules are still and will still be using previous versions of React Native while their migrations to the newest versions happen. We have recently gone through a React Native upgrade at MLS, and the process wasn't simple due to the multiple native libraries and modules our app runs within. So for the time being, I think it's important to keep in understanding that this is an important piece of the architecture in React, and it's going to stay there for a long time. This clearly leads me to take you into the mystery of how the bridge works under the hood and how it is set up inside React Native's core. One of the things that really motivated me to do this talk today was the fact that most of the time we seem to talk about the bridge as this abstract, magical thing that allows the functionality I described before. But personally, I wanted to demystify it so I could understand myself and I could share with you what I found under the hood. Let's start with the way it works. The blue circles in this graph correspond to the activities taking place in the native side of our app. Events such as timers, network, touch gestures, and Bluetooth take first in this side. When you see the old implementation of React Native, these events needed to be initialized at the time that the app was being initialized, even if we weren't going to use them then. Okay, so these events initialize, then a data collection of those events and any parameters associated with them also happens, so they can be notified to the JavaScript side. Once these messages or notifications are ready to go, the bridge serializes this payload and passes it to JavaScript so it can be processed there. From JavaScript, we can also call native methods, and this happens as well here in this process. They are also sent to the bridge where they are serialized again so the native side can process them and finally make the required update. So it's a back and forth process. With the new implementation, Turbo modules will allow the JavaScript code to load our modules lazily and to keep a reference for them so we don't have to go back and forth through this whole process and even use batch JSON messages. Let's take a look to the way the bridge is set up inside React Native's code. In order to have a native module that can communicate with the JavaScript side, we first have to create a module and expose it to the bridge, so this is aware of the module existence. In order to do this, React enables the React Export Module function that registers the module as an external function and makes the implementation of the function available at link time. That also creates a method module name that returns the optional macro. A macro is a set of functions to be performed during build time that returns a parameter called JSName in case you want your module to have a name in JavaScript other than the Objective-C class name. And lastly, it declares a load method that calls the above declared React register module function to actually make the bridge aware of this module. So when the app is loaded into memory, it will call the load method for every class. This, again, corresponds to the logic before Turbo modules. In the new architecture, the use of React export module is not required, since some of these modules might be loaded lazily, and all the UI operations are handled by a series of cross-bridge steps. We actually can see some reference to both the old bridge and the React XX bridge that uses the new JavaScript interface and allows for calling modules in the JavaScript thread. This React XX bridge, or the new bridging, allows us to internally check if a module's block is run in the JavaScript thread. So this can execute synchronously, or if it is not, to dispatch this block in the main thread. Something important to note here is that the new re-architecture will have 4 queues that allow for React to prioritize tasks as they are happening. So we will have the synchronous queue, the synchronous bundle, the asynchronous queue, and the asynchronous bundle, which kind of compose what the concurrent mode is. Depending on what type of module we are using and whether we want to load it eagerly or lazily, we will dispatch that module on the respective queue. The bridge class allows us to do this. Another important method, and this is continue with the next step, of this native JavaScript internal setup is the React register module. This method goes through the modules array, creates an instance of every module, stores a reference to it in the bridge, gives it a reference back to the bridge, so we can call it both ways. And it checks if it has specified in which queue it wants to run. Otherwise, it will give it a new queue separate from all the other modules. In other words, all the React register module function does is to add the class to an array so the bridge can find it later when a new bridge instance is created. All right, so once the bridge has been initialized and set up, it can find everything that was exported. Modules, methods, everything can be done at load time. Let's move into what's after the bridge knows about our modules and it has been initialized. In a background thread, we list all the methods for each module, a call to and call the methods that begin with RCT export, so we can have a string representation of the method signature. This is part of what we call the configuration of modules, and it is important so we can have the actual types of the parameters. For example, if you have, if you want to know at runtime if a method has an ID or a name as a parameter, this would be the way to know if it is an NS string or, for iOS specifically. Continuing with the process of getting a module to the other side of the bridge, we have some JavaScript related setup. After the bridge has been fully initialized, React uses the React JavaScript executor. This is to abstract away the JavaScript execution context. It also allows to do more expensive work, like initializing the JavaScript core on a background thread. It also saves some work since only the active executor will receive the setup call, rather than all the executors available. Then we move into the JavaScript loader, which's role is pretty intuitive. Just loads the source code from whatever provider was specified. Usually, it unloads the source from the packager during development, or it loads it from the disk in production. Once everything is ready, we can load the application source code in the JavaScript core virtual machine that will copy the source, parse it, and execute it. In the initial execution, it should register all the common JavaScript modules and require the entry point file so it can work. The modules that get generated from JSON in these previous steps will be available to JavaScript for us to use. So I will say as a wrap up of this whole bridging process that everything initializes with some calls to the native modules in the native side. Then some calls into JavaScript side during execution happens, JavaScript calls all the methods in the native modules and enqueues these calls that have to be executed in the native side. When JavaScript finishes, the native side goes through all the enqueue calls, and while it executes them, makes the respective callbacks and calls to the bridge. So then the JavaScript side uses these callbacks again to do whatever it has to do with them. So now that we have a better idea, I hope, of the underlying logic of the bridge and how React makes it possible to interconnect with the native side of a mobile application, I think I can go over the process of bridging one of our native modules at Major League Soccer. As again, a reference for those entering the React Native world or a refresher for those who haven't done it in a while. Let me start with the how did we get here. Our web and mobile apps at MLS use Gigia as their identity manager. For those who aren't familiar with this platform, Gigia handles the registration, social login, user profile, and preference management features called. So our app's login screen used to load a web view that will that will interconnect with our web login page, and then subsequently send our users login information to Gigia. We were having several hiccups with this approach because it wasn't necessarily the most performant, and we were missing some of the capabilities that Gigia had to offer with their native SDK. So we decided that we were going to rewrite the whole login experience as a native module so we could use these capabilities written by Gigia in native language. And also, to be honest, it was a great opportunity for us to get more familiar with the native side of our app, which we had been pretty much outsourcing at the time. So here's what we previously had. As you can see, we had a web view with some JavaScript injected in it, and we will let our login authentication repo take care of everything else. As you can also imagine, this was adding some development overhead. Our team was rather small at the moment, and having to switch back and forth between repos so we could be able to debug and change things was adding an unnecessary step to our process and for instance, slowing us down. So we implemented our login screen in both Kotlin and Swift. On the Kotlin side, as you can see here, there are two basic functions being called from the Kotlin side to the React Native side. One of them is the React application context, which serves as a wrap to verify that application context is passed as a param. Exploring a little bit in the React context, what it does is that it creates a Catalyst instance, which manages the gateway to Android JavaScript C. And as a reminder for what context is, for those who don't remember, context is the representation of React Native's environment in Java. It includes the initialization of various native modules and packages. Okay, so this other method is the React method interface, which is used to mark methods that are exposed to the React Native. This applies to the derived classes of base Java module, which will generate a list of exported methods by searching for those which are annotated with this tag. And then this annotation adds a JavaScript callback for each of them, of the methods, right? The iOS side of things looks a little simpler. For our native module, we mainly use the React event emitter class. So our module could emit events from the native side into JavaScript and vice versa. This is just a look to the file structure for our module and the steps we use to package it, right? So in Kotlin, we created the package where the view manager instances are created, and then where our module will be packed. And finally, registering the package list for our native modules. For iOS, respectively, the file structure is very similar. with an addition of a Facebook wrapper required by our third-party provider, also, of course, written in Swift. We have also header files here that might contain variables, constants, and all the functions that our module will require to use. And the M files where the classes of our modules are implemented, as seen in previous slides. As you can see here, the React extern method is used for every method that we need to be available in the JavaScript side, so we can expose it to the bridge and then use it there. And finally, when our bridge has been successfully created and initialized, we get to actually access it from our JavaScript code the way you can see it in this slide. We import the native module class and then call the specific module we would like to use. Now, with that, what's happening under the hood is that the bridge is looking through that list or array of registered modules that it has available and picking the one that we are calling in this particular case. The same thing happens with the methods exposed to that class. We can access them in, once the whole modules has been bridged to the JavaScript side, as you can see here. Okay, and I think that is all from me today. Thanks a lot for staying around to learn a little bit about this thing called the bridge. I am aware that this is a very popular topic among React Native conferences, but it's always worth knowing a little bit more about it. And thanks for the support of to the community.